Welcome to software development. Software does not just happen, it is engineered. In this unit, we cover the Software Development Lifecycle, or SDLC. This is the structured process of planning, creating, testing, and maintaining software systems. It forms the theoretical backbone of Paper 2, giving you the professional context for all your programming and algorithmic work.
Every successful project begins with careful planning. The journey starts with the analysis stage. Here, you gather requirements from the client through interviews and observation to define exactly what the system must do. Next is the design stage, where you decide how the system will do it. You will map out algorithms, choose optimal data structures, and design user interfaces before a single line of code is ever written.
Next, we bring the design to life. Implementation is the coding phase. You will finally translate your designs into working programs using an integrated development environment and library routines. But deployment is not the end of the story. Maintenance is the final and longest stage. You will learn to classify post-launch updates as corrective, adaptive, or perfective as the software evolves in the real world.
How do we organize these stages? Let's look at two foundational models. The Waterfall model is strictly linear. You complete analysis, then design, then implementation, and finally testing, flowing downwards. Each stage must finish before the next begins. It is highly structured but inflexible. The Iterative model, by contrast, builds the system in repeated cycles, producing a more complete version of the software with each loop.
Modern software often requires a different approach. Agile methodology is the modern industry standard. Instead of rigid, long-term plans, Agile relies on rapid, flexible development using short sprints and continuous client feedback. It adapts easily to changing user requirements. You will need to evaluate exam scenarios to justify exactly when Agile is the safest choice for a client's project.
Writing code is only half the job. Proving it works under all conditions is the other. You will explore different testing strategies, contrasting black box testing, which only checks inputs and outputs, with white box testing, which examines the internal logic of the code. You will also learn exactly when to use unit testing, integration testing, and final acceptance testing.
To test effectively, you need the right data. You will learn to select normal, boundary, and erroneous test data to thoroughly validate your algorithms. And when things inevitably go wrong, you will master debugging. Using trace tables, breakpoints, stepping, and watch variables, you will systematically hunt down and fix syntax, logic, and runtime errors in your code.
By the end of this unit, you will have a complete understanding of how software is engineered from start to finish, ready to tackle any scenario Paper 2 throws at you.